Let's do a quick final exam review, going through unit by unit, also known as week by week. Week 1, you might recall, is we were just sort of getting used to dealing with our numeracy, where we're learning about order of operations, what is absolute value. So this week 1 example is indicative. Remember, 3 plus 6 times 4 minus 1. We have to subscribe to this order of operations. We say PEMDAS, which is please excuse my dear Aunt Sally. These are parentheses first, followed by exponents. We don't have either of those, but this is the one that trips people up most. Next, we have to do multiplication and division left to right before we can ever do addition and subtraction left to right. So don't fall into the trap of saying 3 plus 6 is 9. That's going to be wrong. What we have to do is survey and look across our expression and say, where are the priority operations? And you can see that we have multiplication in the middle, so we have to do that first. 6 times 4 is 24, and then we rewrite it. Now we can do our addition and subtraction left to right. 3 plus 24 is 27, minus 1 is 26, and that will be our final answer. So don't fall for it. Make sure you do your multiplication and your subtraction first. Okay, make sure you do those first. And then if we have an absolute value equation, remember what this is saying is that the quantity r plus 6 is 17 units from 0 on the number line. So if you have 0 on the number line, okay, this value r plus 6 is out here at negative 17 and 17. So we set up two specific equations without the absolute value signs to solve this. We say r plus 6 equals 17. And then we also say r plus 6 equals negative 17. Because either one of those, the absolute value is going to be 17. It's going to be 17 spaces from 0 on the number line, which is the definition of absolute value. So r here is going to equal 17 minus 6, 11. R here is going to equal negative 17 minus 6, negative 23. So these are going to be the values for r that will satisfy this equation. Okay? That was all chapter 1. Not much else in chapter 1. I think everybody did pretty well there. We shouldn't be too worried about it. Let's get on to some other stuff that might be a little bit more challenging. In chapter 2, we started dealing with functions and how to compose functions and how to evaluate functions. So let's work on a couple of these questions. So let's say we want to evaluate the function f of x equals x squared plus 3, and we want to evaluate it at f at 2. Well, f at 2 just simply means we put 2 wherever we see an x. So we have an x there, so we put 2 squared plus 3. F at 2 equals 4 plus 3, it equals 7. How about f at a plus 3? Again, we're just substituting a plus 3 in for every x. So here we have an x squared. We're going to put an a plus 3 in there, right, where that x used to be, plus 3. To simplify this, we say, well, we're just going to leave it like that. We could expand this out, but I'm not going to do that. I think you know how to FOIL that out if you need to. But the whole idea here is we just substitute in the value that we're given for x. So that's how we do that's how we evaluate functions at different values. Okay? How do we compose functions? This is what we mean when we say find g of f of x or find f of g of x. So if we have two functions, f of x equals x squared and g of x equals x minus 4, we compose the functions by first starting on the inside out. If we do the f composed of g of x, then we take and put g of x in for every x of f of x. So I like to put parentheses around our guiding function, which is the x squared function. F of x is the one on the outside. So I put the x in parentheses, any x, if I had multiple x's in that equation, which I don't. but I only have the 1x, so I put parentheses around it, and then I fill it in with g of x, x minus 4, and so that's what the composition of x of g of x equals. So what if we did the opposite? What if we did g of f of x? Well, this is saying g is our outside function, so we take g, x minus 4, and we replace the x with our parentheses. And we put f of x in it. Well, what is f of x? F of x is x squared. So then you have g of f of x equals x squared minus 4. So you get two very different values when you compose these functions, okay? That's how we compose functions. That's probably the thing that tripped people up the most in Chapter 2. Don't forget how to do that. Okay, how about Chapter 3? Chapter 3, we learned all about linear equations in Unit 3. Linear equations, okay, which take the form y equals mx plus b, where m is our slope and b is our y-intercept, okay? It's where we cross the y-axis. And so when we're asked a question like, find the equation that passes through the points 2, 2, and -1, -4, we can quickly sketch that out and say 1, 2, 1, 2, 2, 2 is there. -1, -1, 2, 3, 4 is here. And this is the line that we're looking to find. This is the equation of the line we're looking to find. But the way we do this is we first calculate the slope of that line by using our 2 points. Once we have that, then we substitute in the slope, use the slope and a point to find b. So let's do that. So how do we calculate the slope? Well, the slope, m, is the difference in y values over the difference in x values. It's the change in y over the change in x. Well, the change in y is going to be here. It's going to be 2 minus a -4. 2 minus a -4. And the change in x is going to be 2 minus a -1. And it doesn't matter which order you do them in as long as you do them in the same. If we go top to bottom on the y's, we have to go top to bottom on the x's. Okay, so our slope here is going to be 2 plus 4 over 2 plus 1. So it's going to be 6 over 3, which equals 2. All right, that's great. So now we take the slope and one of our points to find b. What does that mean? Well, let's use this 2, 2 point because they're both positive. So we know 2 is the y value equals our slope, m, which is 2, times our x value. Again, we're just using this formula, y equals mx plus b. 2 is the y value. M is the slope. Then we're going to put in our x value, which is 2 as well, right? We're using the point 2, 2. Okay? And then plus b. Oops, I meant to say this is an x. mx value plus b. Well, that's the one thing that we still don't know. So that's what we have to find. So 2 equals 4 plus b. Subtract 4 from both sides. And we get -2 equals b. So our final equation is y equals m, which is 2, right? X, and then our b is -2. So we'll just say -2. Whoops, -2 there, rather than say plus -2. So this is the equation of the line that passes through the 2 points, 2, 2, and 1, -4. We calculated the slope. Then we use the slope and a point to find b. Once we add b, we rewrite it in slope-intercept form, and we've got our solution. So that's the salient point of Unit 3. Unit 4 was all about systems of linear equations, and we can solve systems with elimination, or we can solve it with substitution, or we can solve it by graphing. Okay, so how would we so we have a question here that you might run into. By what constant would we multiply the first equation to eliminate x? Well, here's our system. 3x plus 4y equals 0. So we've got x minus 2y equals 10, and 3x plus 4y equals 0. And it asks, by what constant would we multiply the first equation, this one, to eliminate x? Well, to eliminate the x value, we need to have this top, the one in the first equation, needs to be a negative 3x. That means we would need to multiply the entire top equation by negative 3. So we would have at the top equation negative 3x minus, that would become a plus 6y equals negative 30. And our bottom would stay the same, plus 4y equals 0. We would combine those two. These guys go to 0. This becomes 10y equals negative 30. Y equals negative 3. And then we could substitute this value of negative 3 back into one of the original equations to solve for x. So let's do that there. 3x plus 4 times negative 3 equals 0. 3x minus 12 equals 0. 3x equals 12, x equals 4. And so our solution is 3 and is 4, 3. Our solution is the point 4, negative 3, where 4 is the x value and negative 3. This is the x value and negative 3 is the y value. Okay? But what's important to know is to answer this question, by what constant would we multiply the first equation to eliminate x? We had to multiply it by a negative 3. This is the answer to the question. And you'll see a question like that for sure on your final, so I want you to be prepared for it. Don't forget you can also use the Desmos online graphing calculator to graph those systems of equations to quickly find its point of intersection. Okay? Now in Chapter 5, we dealt with quadratics, right? If you remember, we dealt with quadratics in Unit 5. Unit 5, we dealt with quadratics whose graph makes a parabola. Okay? And these are squared. These are polynomials where the highest order x term is squared. So we learned about factoring and we learned about graphing. How do we graph this guy? Y equals x squared minus 5x plus 6. Let's first talk about how we factor it. We have to find factors of 6, two numbers that multiply to equal positive 6 that add to equal negative 5. Multiply to equal positive 6 and add to equal negative 5. Well, clearly 6 and 1 are going to be the answers, right? So we're going to have 6 and 1, but it's going to be both a negative 6 and a, oh, wait a minute, that's not going to work either, is it? Negative 6 and negative 1, but that's not going to give us a negative 5x. We might have to put this into the quadratic formula. Or maybe I just picked a bad example. Rather than negative 5, I probably should have used a different value here. Negative 5x, we should say negative... Oh, I stand corrected. Let me fix that. This was a negative 5x. I don't know why I don't see it, and you probably do. That this factor is to become x minus 2, x minus 3, because the two factors, negative 2 and negative 3, they multiply to equal positive 6, and they add to equal negative 5. That was simpler than I thought it was. So if we set y equal to 0, we can find where the roots are of this and find where it crosses the x-axis, where the graph crosses the x-axis. So we set each term equal to 0. And then we have x equal to and x equal to 3. So now we have a graph that we know is going to go 2 at 2, 1, 2, 3, 4, 5. At x equals 2 and at x equals 3, we know that it opens upward, right? Because the a term is positive. It's a positive 1, which is the first term. So it's going to go like this. But the big question is, where is this vertex? Well, the vertex, the x-coordinate of the vertex, can always be found by the formula minus b over 2a. And again, in this polynomial, x squared minus 5x plus 6, a equals 1, which is this coefficient. B is negative 5, which is that coefficient, and c is 6. So if we take x equals negative b over 2a, this is the opposite of negative 5 over 2 times 1. So the x-coordinate of our vertex, which is the lowest point in this parabola, this guy down here, is going to be 5/2, which is 2.5. So this is going to be negative 2.5. Excuse me, negative 2.5. Oh, no, it's positive. Of course it's positive. This is going to be positive right here. This is 2.5. Okay, so that's the x-coordinate. And the y-coordinate we find just by plugging negative 5/2 back into the original equation. So y equals negative 5/2 squared. Again, I'm just going to take this and plug in the value of negative 5/2 for x, minus 5 times negative 5/2 plus 6. And then we're going to have, solving this, we get equals 25/4 plus 25/2 plus 6. Well, if we create the common denominator that we need of 4, we'll have 25/4 plus 50/4 plus 24/4. And so that's going to give us 25, 50, and 24. 50, 25, 24, it's 9, and 7, 8, 9, 99/4. So 99/4 is going to be the value. So what's 4 into 99? We'll get a number that makes more sense to us. 2, that's 8. Not 2 and 4 into 19 is going to go 6 times, four times, almost 5 times. So it's going to be and a fourth. So it's going to be 24 and a fourth down, right? So it's actually going to go way down here to just over 24. So it's going to go just over 24. Okay, and that is how we solve it, and it's also how we graph it. We found the vertex right here, which is the point negative 5/2 and 99/4. Okay, so that was a little rundown how we deal with quadratics. We graphed them, we solved them by factoring, we solved them using the quadratic formula. Don't forget how to do that as well. How about Chapter 6? Chapter 6 was all about higher order polynomials, where we dealt with polynomials of order 3, 4, 5, anything bigger than a quadratic. And so let's look at this problem that something like this might show up on your final. 3x cubed minus 5x squared minus 11x minus 3, where we have that as our higher order polynomial, and it says that x equals negative 1/3 is a solution. What is the other solutions? What are the other solutions? Well, we can actually decide to just plug in these other values to see which ones make the function evaluate to 0. Because remember, a solution is where it crosses the x-axis. So you've got a third-degree polynomial here. You got something that looks like this, maybe, right? And what we want to know is what are these values where it crosses the x-axis, right? What are these values where it crosses the x-axis? Now, I don't know that this is the graph of what it looks like, but I can tell you that we know there are 3 solutions because it tells you that negative 1/3 is one solution. What are the other 2? So to find that, we know we care about points that are on the x-axis, which means y equals 0. Well, if y equals 0, we can just set 0 equal to our polynomial, right? 0 equal to 3x cubed minus 5x squared minus 11x minus 3, and put values in that are from our answers to see which ones work. Well, it says there's 3 and 2, there's 2 and 1. These are the answers that they've given us. And 3 and negative 1 and 2 and negative 1. So we have 3 possible values. 3, 2, and negative 1 are the options that they've given us. So let's see which ones work. Let's start with negative 1. That might be the easiest. Negative 1 cubed is negative 1. So that's going to be negative 3 minus negative 1 squared is 1 minus 5 plus 11, okay? And then minus 3. Does that equal 0? Negative 3 minus 5 is negative 8. Minus 3 is negative 11. Plus 11 equals 0. Yes, negative 1 is one of our solutions. Now let's try, well, we can try 2 or we can try 3. Let's try 2. So if we put 3 times 2 cubed minus 5 times 2 squared. Actually, the squared is outside this, and the cubed is outside this. Minus 11 times 2 minus 3. This is going to be 3 times 8, which is 24. This is going to be negative 5 times 4, which is negative 20. This is going to be negative 22 and minus 3. So this is 24 minus 20, which is 4. 4 minus 22 minus 3, which is a big negative number. This is not going to be our answer, right? So we're going to instead try, last but not least, we'll try the value 3, which we expect will probably work. 3, since it's our last choice. 3 cubed minus 5 times 3 squared minus 11 times 3 minus 3. 3 times 27. What's that going to be? Minus 9 times 5, 45. Minus 33 minus 3. 45, 33, and 3. That's 78 and 3, 81. 3 times 27 is 81. 81 minus 81 is indeed 0. Our answers are 3 and 1 and negative 1. So it's going to be this guy right here. So that's how we find, if they give you a solution, if they tell you that one of the solutions is a value, and they ask you what are the other values, you can just plug them into the equations to find out which one makes that function go to 0. Okay, that's chapter 6, where we dealt with the higher order polynomials. Chapter 7, let me get rid of this stuff, and then we'll finish up with chapter 7. Because we already did chapter 8 this week, and you can check out the videos that I made on chapter 8, and that'll show you everything you need to know about rational and radical functions. But for chapter 7, maybe one of the most difficult ones, we dealt with logs and exponential functions. So let's talk about this. Log base 2 of 50. How do you solve that without a calculator that does log base 2? Well, our calculator only does log, which is really log base 10, and the natural log, ln, right? So we have to use the change of base formula. So log base 2 of 50 can be rewritten as the natural, or the base 10 log of 50 divided by log of 2. Again, remember, we're putting the 50 in the numerator, and we're putting the base in the bottom, right? So this is now log base 10 of 50 over log base 10 of 2. If we wanted to, we could have used the natural log of 50 over the natural log of 2. But either of these will go into your calculator. We plug these into our calculator and we get an actual number. But that's how you evaluate a logarithm that's not of base 10 or it's not of base e, which is the natural log. We do the change of base formula. This is called the change of base formula. Okay? Don't forget how to do that. Then just plug it in your calculator to get the answer. How do we solve this equation here? 7e to the minus 2x plus 5 equals 12. Well, we first have to isolate the term with the variable, which is in our exponent. So this is an exponential function, right? This is an exponential function, okay? So we have to isolate it. So we just do our algebra to get the e to the x by e to the negative 2x by itself equals 12 minus 5, which is just 7. Now we divide each side by 7, and we're left with e to the negative 2x equals 1. Okay, well now what does that mean? Well, if we take the ln, the natural log of both sides, then we have an interesting thing here going on where we have one function composed of its inverse function, right? The exponential function and the natural logarithm are inverse functions, which means they return x when you compose them. So this means we're just going to end up with negative 2x out of this whole thing equals ln of 1. Well, ln 1 you can plug into your calculator. That's just a number, right? So then to finalize this, we divide each side by negative 2. And we have x equals the natural log of 1 divided by negative 2. And we just plug this into our calculator to find the answer for x. Okay? Hopefully that makes sense. Let's keep going on these exponential and log functions. How do we solve this guy? Log of x, oops, not base, log base 10 of x, because there is no base listed, minus 2 log of x minus 3 equals 1. Well, you probably remember we have some ways of joining these two logs together. They're both of the same base. They're both of base 10, which we don't write. I just write it there for you so you can see what it is. And logarithms turn subtraction into division and addition into multiplication. So because we see this subtraction, we're going to be able to rewrite this log as log of a big quotient. We're going to turn the subtraction into division, right? And so it's going to be x, this guy, divided by, with this 2 as an exponent, x minus 3, but the exponent comes back in like that, right? This 2 goes back out front as an exponent. So then this equals 1. So how do we solve that? Well, if we have log base 10 of this equals 1, then we just exponentiate each side. We rewrite it in exponential form. So this side is going to be 10 to the 1 power equals x divided by x minus 3 squared. So we can finish this up. 10 equals, so now we can multiply the x minus 3 squared into the top, and we have x minus 3 squared times 10 equals x. Let's FOIL this out, and we're going to have 10 times x minus 3, times x minus 3 equals x. Okay, 10 times x squared minus 6x plus 9 equals x. 10x squared minus 60x plus 90 equals x. Subtract the x, 10x squared minus 61x minus 61x plus 90 equals 0. We set it equal to 0 so that we can factor it and solve it, right? Actually, yes, well, not only that, because we subtracted x from both sides, we actually are left with 0. And now we can plug this into the quadratic formula to solve. I don't think we're going to get there by factoring, because our factors of 90 are not going to add up to negative 61. So we would put this into the quadratic formula, which is minus b plus, the x value is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. Don't forget that. And what does that mean? That means our a, b, and c, a equals 10, b equals negative 61, and c equals 90. These are the coefficients of each term in our quadratic, right? So negative b, so this is going to be the opposite of negative 61. So it's going to be 61 plus or minus the square root of negative 61 squared, okay, minus 4 times a, which is 10, times c, which is 90, all divided by 2 times a, which is 10, which is going to be 20. All right, and we would work all this out. My guess is this square root probably equates to some perfect square. If not, it's hard to say. But we would I would have you work that out as an example. I don't need to do it on this video, but this is how we use the quadratic formula. So let's take a look and see how we solve some of the others. What else we got left? Log of x plus 1 plus the log of x plus 5 equals 1, and that it says which of these, where do we find the value of x? Well, again, we can say log of x plus 1, this plus symbol means that we can turn it into a multiplication problem. Log base 10 of x plus 1 times x plus 5 equals 1. Well, again, this is going to be 10 to the 1 over here. And if we take 10 to this whole guy, we end up with just what's in the middle. X plus 1 times x plus 5 equals 10. So we can say x squared plus 6x plus 5 equals 10. X squared plus 6x minus 5 equals 0. Well, this is going to be -5. This is going to be, how do we get -5? Product of -5. -5 and -1? Nope, because we got to add them here. This is another one where to find the answer. Where is the value going to be? Is it going to be between 0 and 1? Is it going to be between 1 and 2? Or is it going to be between 2 and 3? Well, let's see. Let's plug each one in. We have how many unique values here? We have 0, 1, 2, and 3. 0, 1, 2, and 3. Let's plug in each value and see what we get. Okay? We'll plug in 0 and we get -5. We're going to evaluate this function. Okay, we're going to evaluate this function. Okay, at each of these different values. And so when we evaluate it at 0, we get f of x, f at 0 equals -5. F at 1 equals 1 squared, which is 1 plus 6 minus 5. That's going to be 7 minus 5. That's going to evaluate at 2. F of 2 is going to evaluate to be 2 squared, 4 plus 12 minus 5. That's going to be 16 minus 5. That's going to be 11. And f of 3, last but not least, is going to be even bigger. 3 squared, 9 plus 18 minus 5. 9 minus 5 is 4 plus 18 is 22. So where is the value? The value is between where it changes sign, right? It's between here and here, 0 and 1, where we go from a negative value to a positive value. And why is that? Think of the graph. We're going from below the x-axis, where the function evaluates to -5, right? Where the function evaluates down here to -5 somewhere, up to where it evaluates at a +2. So up here. And so when we do this, we know we've crossed the x-axis. This is where one of the solutions is, where one of the roots is. So we know it's where we have crossed over from negative territory to positive territory. It can't be between 1 and 2 because we stayed in positive territory, and it can't be between 2 and 3 because we've stayed in positive territory. So it's where we cross between negative to positive or positive to negative, which is where we find a solution. So our answer is going to be between 0 and 1, and that's simply how we find that out. Okay, so that was a quick review for your final. Hopefully these types of questions will show up on your final, and you will have the benefit of having seen me do them again so that they will help you. I wish everybody the best of luck, and please don't hesitate to shoot me an email if you have any questions or comments. And I wish everybody the best of luck in finishing up strong in the course. And don't forget to do all of your written assignments as well, because those points can be important towards your final grade.